Adding and subtracting polynomials. So it says simplify the following polynomial expressions. Write your final answer in standard form. Okay. So A and B are both addition. So we're going to find the sum of these two polynomials. So A, we have 3x to the 7th plus 7x minus 4 plus the x squared minus 2x plus 5. So when we're adding polynomials, we really just add their like terms. We combine their like terms. So the 3x squared is going to combine, when we're going to add it to this polynomial, is going to combine with this 1x squared. The 7x is going to combine, it's going to add to the negative 2x. And the negative 4 is going to add to that other constant term, that's just the 5. So when we're adding and subtracting polynomial expressions, we're adding and subtracting to their like terms. So a 3x squared plus a 1x squared would be a 4x squared. And I did the x squareds first because we want it in standard form. So we want the biggest exponent to come first. Next, we have 7x plus a negative 2x. Well, 7 plus negative 2 is 5. So 5x. And remember that we're adding. This is an addition problem. Then negative 4 plus positive 5 is 1. And there we have it. This froze. That's fun. Oh, there we go. 4x squared plus 5x plus 1. B, again, this is an addition problem. So we're going to do a standard form, right? So we want to start with the highest exponent. So I have x to the third. But there's not another x to the third in this problem, so it doesn't combine with anything. So that doesn't combine with anything. Neither does even the 4x squared. We see that doesn't. There's not another x squared. But what can be added would be this 10x and this 1x, and this positive 8 and this negative 2. So we still have that x to the third. It just wasn't added with anything. Same thing, we still have a positive 4x squared. The 10x plus the 1x would be 11x. And the 8 plus the negative 2 is 6. So when we're adding polynomial expressions, we're just adding the like terms. C is subtraction. Now, you could use the same method that I was kind of doing there, except just subtract, right? This is subtraction. So does this one. We could just do the same method and just subtract the like terms, but it can get a little messy with subtraction, so I kind of have a different suggestion. So since it says subtraction, I'm going to change the signs of everything in this second parentheses. And a lot of people like to kind of put a -1 and just distribute a -1 to everything in here since we're subtracting that one. And that's going to change that to a negative 3x squared. Then that's going to turn to a positive 5x and then a -1. So it just flipped the signs of everything in there. And I'm going to rewrite this expression. Okay, so when you have subtraction, you don't have to do what I just did there. You could just kind of subtract them in a similar fashion the way that we added in A and B. Although sometimes it can get a little messy with subtraction. So my suggestion is to do this sometimes. So now we can just combine like terms like normal. Maybe I'll underline them in blue this time. So the 4x squared can combine with the negative 3x squared. The 2x can combine with the 5x. And the negative 6 combines with the negative 1. So 4x squared and then minus 3x squared would just be 1x squared. A 2x and a positive 5x would make 7x. And a negative 6 and a negative 1 make negative 7. So I'm just kind of combining like terms, in other words, adding their like terms. So again, with subtraction, I like to distribute a -1 first and then just combine my like terms, add my like terms, kind of make it an addition problem. So I'm going to do the same thing with D. I'm just going to kind of distribute a -1 since I'm subtracting that quantity. So this is now going to become a -4x squared. This will become a -6x, and this will become a +2. And I'm just going to rewrite the first one. Okay, so now I'm going to combine my like terms, or just kind of add my like terms. So the x, oh, this is an x to the third. Whoops. That's messy. Let me just rewrite that. Okay, so what combines here? I see an x to the third, but there are no other ones. I also see a -4x squared, but there are no other ones. But this x will combine with the -6x, and the +7 will combine with the +2. So if I want it in standard form, I'm going to rewrite my x to the third. I'm going to rewrite -4x squared. Then my 1x plus my -6x. If I combine 1x with -6x, that's going to be -5x. And then combine 7 plus 2. 7 and 2 is going to make 9. Let me just do 2 more. I'm going to do f. So f is another addition. So you don't need to really worry about this -1 distribute. Like, there's nothing to distribute. You're just addition. You're adding the 2. So you don't really need to kind of have that middle step there. You're just adding the 2. So the 3x squared is going to combine with the 4x squared. The 5x is going to combine with the -5x. And then the -10 is going to combine with 5. So 3x squared plus 4x squared, that'd be 7x squared. Now, the 5x plus -5x would just be 0x. So those kind of just cancel out. 0x, 0 times x is just 0. Anything times 0 is 0. These would just really cancel out. You can write 0x, just not needed. -10 plus 5 would be -5. Let me do one more. Let me do h. H has a subtraction. So again, my suggestion is kind of put a -1, distribute a -1, which will just change the signs of everything in there. So that +3 now is going to become a -3. That's going to become a -2x. It's going to become a +x squared. I'm going to rewrite the first one and then combine the like terms. So the 5x squared is going to combine with the 1x squared to make 6x squared. The -2x doesn't combine with anything, so I'm just going to write -2x. But the -3 combines with the 8. So -3 plus 8 is 5. And there we go. So that's how you do it. I'll let you do the rest.